is uh, supposed to bear that temperature, right? But this insulation is very poor. That's why I think you were having this problem. So what you all did, you got new holders to complete that last experiment, or what you did you have you done? You have not done experiment? Nicholas, did you have this problem?
Um, I actually have not completed the experiment yet. No, I plan on getting a new holder over the weekend.
Okay, but you did not, your batteries did not heat up.
No, my holder melted.
Your holder was melted, but you did not complete the experiment yet?
Correct.
Okay, okay, okay. So, but next time when you get this kind of a thing, get the thing which has the thick insulation here. Like here, it's, if you can see, this is very thin. The plastic is very thin, but the plastic should be thicker so that it should not be melted. The other thing I noticed is in the last lab that there are two types of the melting or the problems. Like if it happens, you just put in the holder and then start heating, then we can say that it's a holder problem and we just put it like in the sideways or something like that, it's okay. But if you just put it in the circuit and started heating up, then it means that you have shorted something in the circuit, okay? So there are like 50% chance that if this is melting, either it has melted after putting it in, or this is faulty. So it's not necessary that this is faulty. It may be possible that your circuit is not maybe shorted, or you put it in the same hole. Okay, Harris.
Um, I also noticed that when I used a different brand of batteries, I got more accurate readings for the experiment. So I
Okay, so
used Duracell batteries instead, and my readings were similar to what they should be.
okay, yeah, that is possible. Okay, I'll just ask one by one. So let's see whose problems are resolved and whose are not. Okay, Harris, did you have this problem?
I didn't have the problem. I mean, I haven't really finished it yet. But when we were doing it last week, I wasn't having that problem. Just
Okay. So next time, yeah, just I want to make a little bit, you should be careful. When you put the battery in, make sure that the spring should not be tilted, okay? Just make sure that it's in the straight point so that you may not have this problem in future, okay?
okay, no problem.
Yes, okay. Amanda, did you have this problem?
I didn't have it last week, but I also didn't fully complete the lab yet.
Okay. Benjamin, did you have this melting problem? Benjamin, we cannot hear you. Benjamin Winkler. Okay. Okay, it's fine. Yours was melted and you ordered a new one. Okay. Okay. I will ask one by one, okay? Because I want to know how many of you have this problem. Chris, do you have this problem?
I didn't have the problem. My battery snap was fine.
Okay. Just to avoid the problem, make sure when you put the battery in, the spring should be straight, and just avoid any short circuit, okay? Okay, next one is Adeline. Right, I'm not sure if I did pronounce this right.
Adeline?
Yes, yes.
Okay, yeah, that's me. I put it in the chat. Mine had melted as well, but I ordered a new one online. But now that you had mentioned the thing about the spring, my spring was not in the center of like the bottom part of the battery. Maybe that's why.
Yeah, I figured out then yesterday when I was trying the experiment, I just didn't care when I was putting the battery and it was tilted.
Mm-hmm.
So I feel that this insulator is actually very poor, and it's actually broke down. That's why it was heating up. Okay.
Yeah, so I think it was just that. So mine is supposed to get here on Sunday.
Okay. Yeah, next time if you get it, it should be very thick. I mean, I'm not sure.
It looks a little better than the one that we got because the one we got was like very thin.
Very cheap. Okay, thank you. Okay, Eric.
I didn't have any troubles. My
Okay.
my holder was fine.
Okay. Herschel said that he has no problem. Okay. Janik, Hawks.
It's Janika.
Yes, sorry. Janika.
I don't have any problem with my battery pack melting, but the spring isn't exactly like straight anymore, so I probably want to get a new one then.
Yeah, maybe it'll happen like mine as well. Yeah. Just be careful. I mean, it's okay to, have this problem, but just be sure that no one hurts, right? So take it out in time, and because these are not expensive, but we do not want to harm anyone. So that's why I just want to make sure that you realize it and take it out if it is heating or something. Okay. Maxwell?
I didn't finish the lab yet, but when we were in class, I didn't have any problems.
Okay. Nitya?
I didn't have any problems. After the lab last week, I did have some weird problems with my voltmeter, but like I got it fixed now.
Okay. But what do you think? What was happening?
I'm not really sure, to be honest. I don't think the wires were pushed in all the way when I first got them, and so I had to I accidentally sat on and pushed through.
Okay, that's fine. Okay, Rodney.
Yeah, mine seemed to be okay. I still might get a new one because, just in case for safety reasons. So yeah.
Okay. Sam.
All good here.
Okay. Sarab, I actually notified by Sarab that you all were having problem. I think one of the person showed me in the lab too that they were having problem, but in that time I was thinking that it's just a one person. So I know Sarab fixed it, right? Sarab, you got new ones, right?
Yeah, I had new ones from like the lab that I did over the summer.
Okay. So Thomas again. Yeah.
I didn't have any problems with my batteries, but my voltmeter was reading higher than the battery voltages. If that makes
It's okay
sense.
because your resistor maybe is in the lower side of 5% tolerance. That's why maybe. You understand what I'm saying?
Yeah, but if I read the voltage across the battery terminals, if I read the 9-volt battery, it gives me 11 volts.
Gives you what?
My voltmeter reads 11.
Mine were doing the same thing. I just switched to a different brand of batteries. It's probably because the batteries are older.
I can try that.
Oh, I couldn't understand what you were saying. Just a minute. So you are saying that you were checking across the battery terminal and it was not giving you exact number. I mean, if it is a 3 volts battery, how much you were getting output and at output?
I think it was 4.5. If I read the regular 1.5 volt.
Because we cannot, one more thing is, because in this case, in this holder, we cannot measure 1.5.
Oh, I know that, yeah.
But what you were saying, that you were measuring 3 volts, right?
Yeah, but it was more than 3.
Yeah, we will learn about that in this lab, why the difference of voltage is happening, okay?
Yeah. All right.
Yeah. Okay. Yolis?
Nothing like melted or anything on the first lab. It was just random readings during the different circuits. Like the voltmeter, it wasn't giving me anywhere close to what they should be. So I just switched batteries and it started being more accurate.
Oh, okay. Okay. Because this is the first time actually they have distributed kits. So we should give them margin of error as well, because they didn't also know that how they will work, because we don't know any companies or something. So I think, yeah, if they are not too expensive and if they are not hurting anyone, you know, we should be good. Okay, so let's start today's experiment. So this, I mean, this time what I did actually, I am actually posting the pictures as well, so that it may not be difficult for all of you, okay? So this, in this experiment, and today, like last time we have done Ohm's law, but today we will be doing a voltage divider circuit that we have done in the simulation. Previously, we were not having the kit, so I didn't know that which resistors we will be having. So today we will be trying to accommodate the resistors we are having, okay? Instead of the resistors that we had used in the simulations. So we were doing series resistance before, okay? So one minute. So that's so you know how it works, and we know how to calculate the voltage. How to use the voltage divider rule and calculate the voltage across them. So now what I want, as we don't have 1 ohms resistance here, so first you need to create, make the voltage divider on the breadboard, okay? And as we cannot use, we can use 9-volt battery here. So use 9-volt battery to get the output across this, okay? Let me use the pointer. And today I want you guys to have the breadboard and resistors ready. I want to see the experiments like that how you are making it on the breadboard. And another thing is, from this lab onwards, it is mandatory for you guys, because it's a part of the lab, to put the pictures of your circuits in the lab report. Because as we are not doing in person, so I don't know how you are making the circuit. So put the pictures in the lab report, okay, of your circuits. Okay, and so we are making the voltage divider circuit here, and then we will replace it with 1 mega ohms and 10 k ohms, because these are the resistors we are having. And after that, you have to design the circuit that outputs 2 volts using not 9-volt. I will suggest using 9-volt supply. So what near you can get using your provided resistor, okay? That you have to do. It not necessarily be exactly 2 volts. The other thing is, picture of your hardware, you have to include actual values of R1 and R2 when you measure with your DMM. And these things you have to use input voltage, input current, output voltage resistors R1 and R2, and then percentage error. So there are 2 types of the resistors. One is that you will measure, and the other is that you will be knowing the value of, okay? How does the multimeter, okay, so we will know that. Okay, so this is the circuit that I will ask you to miss. Can you see that?
Yes.
Okay, so if you see this, so it's a voltage divider circuit. So the 2 resistors should be in series. So when they are in series, they should follow the same vertical line. Then they are having this positive rail, power rail, and the negative rail. So you will connect your battery across this 9 volts battery, okay? So in that case, you will be able to measure the voltage across that. Is it helpful? Is it clear?
Yeah, it is.
Pictures help out a lot.
Yeah, okay. And then if you see this, this is how I want you all to do the current measurements. So for the current measurements, you know that you have to break the circuit, right? And these two wires, I will put it in after breaking the circuit. So this will measure the total current in the circuit for you, right? When you will put your ammeter on it, or DMM, putting it on the current, like ammeter, right? Am I clear about that? Do you have any questions?
Yes, you're fine.
Okay. So this is the voltage divider circuit, okay? As you have done the calculations before, so we don't have to go through calculations again because you have done it before in simulations. So we are just doing that, how you can do it practically, okay? So this is the voltage divider circuit. First, you have to do it with 1K, and then you will use 1 mega ohm and 10K ohm. So 10K ohm resistance, you can see that you have this in the kit, like in this, it is mentioned as 10K. But 1 mega ohm is there with LEDs. So this is your packet if you have, and in that the resistors are 1 mega ohm, their list is there, and you can see that you have 2 1 mega ohm resistors in it, right? So you can get 1 mega ohm from there. Is it clear?
Yeah.
Okay. Okay, and then you need to do other things. Okay. So then we will try what you should say, parallel resistance. And okay, so we don't have these resistors like 1.2 and 2.2. So what I ask you to do 1 kilo ohms in parallel, and then you will measure your current and voltage across this, and you need to change your calculations for 1 kilo ohms, and then you can see that you will add another 1 kilo ohm resistor because we are not having 3.3 kilo ohms. And there's the questions are same, but in this time you will see how practically it will change. Then you are having this parallel combinations, right? So these two resistors are in parallel combination. You are having positive power rail to that and negative power rail to that. Is it clear?
Yeah.
Okay. And then this and this is the same circuit. Okay. What I have done differently here is I was having very less space here in this circuit area. So I shorted these two areas, okay, so that I can use more space here, okay. So they both circuits are same. The difference is in this I am using only this circuit area, but as these two are not connected, so I am shorting them here and put in the same place, okay. Is it clear?
Yes.
Yeah.
So why I'm doing that, so this is the total current measurement of the parallel resistor, okay. I just took this, what you should say, the leads out and doing the total current measurement. And what is this? This is the total current measurement when I'm using both areas, okay. And this is the current measurement in one of the branches, okay. So when you will do voltage measurements, you know that if your circuit is connected like that, you just need to put your, what you should say, digital multimeter across the legs and you will know the voltages, right? But here, you have to put the DMM in the circuit to measure the current. So here I am breaking the second branch, this branch, and I want to know the current in the second branch. That's why I'm breaking it and putting the leads to know the current. Is it clear?
Yeah.
So the difference between total current and the branch current is that in the total current, you break the circuit from here because that is the circuit from where the total current is flowing. But in the branch current, you are breaking the circuit from here. Okay? Is it clear? Okay. So now we are talking about real batteries and ideal batteries. So many times it happens that the voltage that you are seeing is not the accurate voltage. Okay. So why it's happening and how we can solve the problem? How can we know what's the actual voltage is? That we will know. But one thing comes in my mind. So you guys have not completed lab 3 yet. You are planning to do it on weekend?
Yes.
Yeah.
Okay, so Ohm's law, the part in which we were doing Ohm's law, that is left. What part is left? I mean, because today I want you to try this voltage divider circuit for at least one value, and similarly this parallel circuit for at least one value. You are not supposed to do everything like the changing the resistor and everything, but you have to show me that this is my voltage divider circuit for 1K ohms, and similarly parallel circuit for two 1K ohms of the current divider. So I just want to make sure so that you don't have problem afterwards, because today is Friday and I will be able to answer by Monday, right? So if you will be having problem, I may not look into your emails tomorrow or Sunday. So I'll be starting looking at on Monday. So that's why I want to make sure that for this lab you are good. Okay. Okay.
Thank you.
Okay, thank you.
Okay. So this is the battery model we were having. So what I want you to look into it. So this is the voltage that normally we get out of the battery. So this is EMF voltage, and this is internal resistance voltage across that. So how we will differentiate between them, we will know. So what you need to do is you need to have this holder, okay? And you need to measure the open circuit voltage. I'm doing right now. Let's see. Bring the book. I did not bring the book today. Oh. Okay. So I will. I'm breaking the remaining part of it. Okay, so this is on the voltage, right? I am turning it on and I'm measuring the open circuit voltage. Open circuit voltage is when you did not put it in the circuit. So it's showing 3. It's hard to hold it. Just a minute. wires are too long and or one more thing I can do, instead of putting in the circuit, I just take the wires out and then check it. 1 minute. So I'm seeing 2.95, right? Is it right? Yes. Yes, so this is the open circuit voltage when you have not connected your circuit, right? Then when you connect batteries with 1 kilo ohm resistors, then you measure the resulting voltage, okay? This is the similar as Ohm's law, but this is just to know how much voltage change when you put the voltage in it, okay? When you put that in the circuit. So I'll show you. So what I have done to check the open circuit voltage is that I have connected my battery like that without having any, what you should say, circuit in it. And then I just took the wires out from the terminals and check it. The better is that you just check it by taking out, but it was hard to do that. So I just, without circuit, I just check it like that, okay? So the 2.95 or 98 I was getting. So now I will put it with 1K ohm resistor. To see the voltage. Okay, so I put it in the 1K ohm resistor in that. Okay. And then I am checking the voltage across it. So it's 2.92. Previously I was seeing 2.95. But it's not increasing from 2.92, okay? Okay, so what is the difference which I'm trying to make here is that how you will find your internal resistance, right? What is happening? So if you look into here, so this thing is, so this thing is your VOC. VOC is the voltage that you have measured in open circuit. Okay, then this is your current that is you got from after connecting 1 kilo ohm, right? So let's say you have V over R, that is your I. So in that, we have 2.92 divided by whatever resistance you have, 1K here. So just put it like that. And then you will have V OC minus V, that is the voltage that you have, is equal to IRI. Okay? And then you will have RI will be VOC minus V divided by I. Does that make sense? Do you understand what I'm doing?
Yeah.
Anybody else has a question? So this I will be the current that is flowing in the circuit, and that's how you will know what is your internal resistance is, okay? So whatever you are measuring at output circuit voltage or OC you will write it down as open circuit voltage, and then you will put a 1K ohm resistor in it and measure its current and voltage, or you can also write it like this. No, I'm wrong. Just a minute. I should take this off. VOC by R, it should be VOC by R, right? Yeah, I mean to say you just have to replace the current here. Into R minus V by R, so it will be 1 over R, right? Something like that, okay? So either you can find it like this, VOC minus V divided by your I, or you can also do this, okay? So that will help you finding your current, sorry, it should be R. Okay, because V over R should be R. Okay, so that's how you can find your internal resistance. So you will try with different values of resistance, like try, so you have 1K, you have 10K, 4.7K, so you will try for different values of resistors, and you will see that that what will be your internal resistance does this maintain its value, or it will whether it changes your internal resistance value. Okay, and don't plug it in for a long time, because as we are connecting the resistor through it, it actually allows for the power dissipation. But previously, when they were doing labs in the class, they were having those resistors which are 5-watt power rating, or they can dissipate power more quickly, so that you can see battery discharging across the resistor. So in these resistors, which are very low power rating resistors, your battery may not discharge that quickly, but still, if you put the resistor and put it for a long time, your battery may be discharged. So don't put it for a long time. So so you need to answer these questions, and that you will know after doing that. So for now, I want you to try voltage divider and current dividers and the parallel circuit and this internal resistance, and then we can talk about it. Okay? Am I clear?
Yeah.
Okay, one thing I can show you, maybe just a minute. I can also try one of the voltage divider to show. So this is the voltage divider circuit I have shown you, right? Right? This is the voltage divider circuit in which the resistors are connected in series. So I'll just measure the voltage in front of you so that you know what is going on. So this is 3 volts. So I'm checking it across both the resistor, and it's swapping. So what I'm doing, if you see this, so if I put my leads across both the resistor, it should give me total voltage, okay? Right, 2.90, something like that. Okay, and if I check across one resistor, it should give me half of the voltage if the both resistors are of same, okay? Can you see that? Am I clear about that?
Yeah.
Okay, and one more thing you need to know, that you also we also studied that voltage divider is also, when you connect it to measure the reading, it's also actually in the parallel of the circuit. So its resistance is also playing the part. So the calculated value will be the value that you calculate using formula, and the measured value is the difference of the value that you are getting. So you need to, you know, find the difference of the error, and then you will know that how much voltmeter is affecting the original circuit. Okay, am I clear about that?
Yeah.
Okay, so let's start the experiment and let's do it. I'm turning off my camera, and you guys start with the voltage divider and show me, and then we will know what problems you are getting. Okay. I already posted it in the Canvas, so you can access it. So I will stop the